Hello, here we are again with another video, this one on the Pure Maths Year 2 content. Final video on Chapter 1 of this textbook, which is on algebraic methods. And we're going to be looking at more stuff to do with algebraic fractions. Now, before we get into all that, I want us to remind ourselves about something which I think we've seen before. The degree of a polynomial expression is equal to the highest power of the variable in that polynomial. So on the screen, I've put a polynomial expression. I'd like you to just stop the video for a second and just work out what is the degree of that polynomial on the screen, please. Okay, so I will tell you that this is a polynomial of degree 3. Okay, so the reason for that is because if we look at the powers here, we've got, well, we don't have any x term in here, so that's kind of x to the power 0, really. This is x to the power 1, but this is an x to the power 3. And so that's the highest power. Power 3 means that the polynomial we've got here is a degree 3 polynomial, which we would often refer to as a cubic polynomial. Now, the reason why I wanted to remind you about the degree of a polynomial and that definition is because it's very important to understand when an algebraic fraction is improper. So you might have heard of improper fractions when we're dealing with numbers or numerical fractions, but have you heard of improper fractions with algebraic fractions? Well, here's the definition. An algebraic fraction is improper if the degree of the numerator is greater than or equal to the degree of the denominator. If that isn't the case, then we would say that the fraction is a proper algebraic fraction. Now let's see if that makes sense to you. I've put 3 fractions on the screen, algebraic fractions. I want you to tell me, please, which of these 3 fractions are improper fractions? Okay, let's see what we think. So what about fraction A? Well, the degree of the polynomial in the numerator here is degree 1. Now the degree of the quadratic on the bottom of the fraction there in the denominator is degree 2. So that means that the degree of the numerator is not greater than or equal to the degree of the denominator. This is a proper algebraic fraction. Okay, right. What about B? Well, both of the numerator and the denominator are degree 1. So according to the definition, because the degree of the numerator is equal to the degree of the denominator, that's called an improper algebraic fraction. So that's an improper one. And then in fraction C over here, we've got a degree 2 polynomial in the numerator and a degree 1 polynomial in the denominator. Because the degree of the numerator is greater than or equal to the degree of the denominator, this time it's actually greater than, that's also an improper algebraic fraction. Now, one of the things that we need to be able to do is we need to be able to take an improper algebraic fraction and write it in a form which involves only a proper fraction. I'm going to show you an example of what we mean here, but it's going to involve this technique which we learnt already called algebraic division. So the example on the screen here, you can see what we've got is we've got the fraction x cubed plus 3x squared plus 10, all divided by x squared plus 5x plus 4. And that's an improper algebraic fraction because that degree of the cubic on the top of that fraction, degree 3, is greater than or equal to the degree of the quadratic, degree 2, on the bottom of the fraction. So what we're going to do is we're going to do a bit of algebraic division here now. Here's how it's going to work. We're going to take the numerator and divide it by the denominator, and hopefully you've seen this process before and we recognize it. I'm going to go through it as quickly as I can. So I'm going to first of all work out what I need to multiply x squared by to get x cubed. Well, that's just an x. Multiply all of this by x and subtract it away. Okay, remember this process? All right, let's see what we get when we subtract it away. So the x cubed minus x cubed vanishes, which is good. 3x squared minus 5x squared becomes minus 2x squared. I didn't have any x terms here, so I put the placeholder of 0x in here just to make sure I didn't mess up. So I've got 0 minus the 4 is the x coefficient here, so minus 4x, and then we bring down the plus 10, and we'll do it again. Okay, so another round through. X squared times minus 2 is going to give us the minus 2x squared that we want here. Multiply everything else by negative 2 as well. I think we get that. Subtract it away, see what we end up with. And I think here we're going to end up with a 6x plus 18 at this stage. Now, at this point, I have to stop because what I've got here is I've got a linear function here as the remainder, and here's a quadratic function here. So the degree of what I've got down here is less than the degree of what's up here in terms of that degree of those polynomials. So I've got a remainder here of 6x plus 18, and I've got sort of my answer up here. X minus 2 is what I call my quotient. So hopefully you remember those words here. But it means that I can write my answer to the fraction here is in this form. So my quotient was x minus 2, but I still had 6x plus 18 as the remainder, which still had to be divided by the x squared plus 5x plus 4. And there is my answer. So, quick recap of what I did, just so you can see the whole process here. In fact, let's have the whole thing on the screen here so we can see the whole thing. So, what I did was I took my the thing on the top of the fraction, I divided by the thing on the bottom of the fraction, used algebraic division, and I went as far as I could until the degree of that remainder was less than the degree of the thing that I was dividing by over here. The quotient became part of my answer over here, and the remainder still had to be divided by this, so that's the proper fraction which I've ended up with over here. So please do make sure that you maybe rewatch that video if you didn't catch all the details there. Make sure you understand every step of the process. Once you're happy, have a go at the question on the screen and pause the video and restart it once you've got your answer. Okay, so how did you get on with this one? Here's my answer. I'm not going to go through it all line by line here, but you can have a look and see if you disagree or agree with anything I put down here. My remainder down here at the bottom is x plus 9, and the quotient I ended up with was 2x plus 3. So that means that my final answer here is that the algebraic fraction can be written as 2x plus 3 plus proper algebraic fraction here, x plus 9 over the x squared plus 3x minus 4, and that is the answer you should have ended up with. Okay, so hopefully that doesn't look too different from when you've been doing algebraic division in the past. Maybe we didn't worry too much about the remainders in the past, but hopefully you're getting on with that okay. Now you may be thinking to yourself, well, why do we care about proper and improper fractions anyway? What's wrong with an improper fraction? Well, the issue with an improper fraction is that we can't actually put it into partial fractions form as it is. So if we have an improper algebraic fraction and we want to put that into partial fractions form, the first step has always got to be to do what we've just done, to express that improper fraction in a form involving only a proper fraction. And most of the time we might want to use algebraic division to do that. Only then can we split the proper fraction into partial fractions. Let me show you an example of what I'm talking about here. So on the screen, we've got a fraction which actually I was working with earlier on. Remember earlier on in this video, I took this fraction here and I wrote it in this form which involved this improper algebraic fraction. Now, if I want to take this and put it into partial fractions, I can't deal with it here in this form because the degree of that numerator is greater than, in this particular case, the degree of the denominator. And it means that when I try and combine my fractions together, my numerators are not going to match up, and that's the reason why it doesn't work. So instead, I've got to do this bit first, and then with the proper fraction that I've got there, I can then put that into its partial fraction form. So let's take this fraction here, and let's see if we can just put this into its partial fraction form. So the first thing I want to do is I might want to factorize that that denominator there. So I think that's going to factorize to x plus 4, x plus 1, because that's going to allow me to say that my partial fraction form must be a over x plus 4 plus b over x plus 1, like that. Okay, so remember how this works. Let's look at combine these together and consider the numerators. I think if I do that, I'm going to end up with a times x plus 1 plus b times x plus 4, and that's got to equal 6x plus 18. And if I use my favorite substitution method here, let's put x equals -1 into here. That's going to give us, what are we going to have here? I think 12 on the left-hand side, and then that term's going to vanish, and we're just going to end up with 3b, which means that b equals 4. X equals -4 means that we end up with, I think, -6 on this side, and then -4 plus 1 is -3 times a here, and that term there involving the b just appears. So we end up with a equals 2. And so therefore, looking at what we've got over here, the whole thing must become 2 over x plus 4 plus 4 over x plus 1. Hopefully you're getting fluent enough with partial fractions now that you follow that process. Okay, so finally, let's write down the whole thing up here, and I'm just going to sort of jump back up to what I've done here. So the whole thing as partial fractions is going to become x minus 2 plus what we've ended up down here, which is 2 over x plus 4 plus 4 over x plus 1. And there would be my final answer. I've expressed this improper fraction as partial fractions. Now, I bet you're itching to have a go at one yourself, right? Of course you are. So on the screen, here's the question for you to do. Now, it's the same one you've already worked with. So in fact, you've already done, earlier in this video, you already did the first part of this process. You've already expressed this improper fraction into a form involving only a proper fraction. So you've done the first part. Can you now do the second part and then put the whole thing into partial fractions? Okay, how did you get on with this one? So this was our starting point. This is what you already did yourself earlier in the video. We worked out that this improper algebraic fraction could be written in this form, and here's the proper fraction over here. So the next thing you should have done is you should have recognized you need to factorize the denominator of this proper algebraic fraction over here, so that we can then try and split it up into partial fractions. So we should have ended up with, I think, x minus 1 times x plus 4. Factors in the denominator there. And then I'm just going to jump to the answer here. This algebraic proper fraction here, when you split that up into partial fractions, you should have got plus 2 over x minus 1 minus 1 over x plus 4. Do you agree with me? Hope so. And there we are at the end of the chapter now. The techniques which we're learning in this chapter, particularly partial fractions and all the different forms that we might need to think of, are going to be very, very useful later on in the course. There are going to be places where we're going to take our algebraic fractions and we need to put them in that partial fractions form before we can go any further with some of the stuff we've got coming up. So it's really important that you do consolidate and get really, really fluent with this process, recognizing when to use algebraic division, recognizing what the form of the partial fractions are going to be. And so please do consolidate this particular part of the technique by looking at exercise 1F and exercise 1G of the textbook. But for now though, that's the end of this video, and I'll see you again for chapter 2.